Here I have a circle with radius 1, and it's centered at the origin. I can call this 0 degrees or 360 degrees. If I split 360 degrees into 4 equal parts, this would be 90 degrees. This is 180 degrees, and this is 270 degrees. I can also think of this as 0 or 2 pi. So if I split 2 pi into 4 equal sections, if I split 2 pi into 4 equal sections, this is pi over 2. This is pi. This is 3 pi over 2, and that's 2 pi. Are we clear that this is 2 pi, and then this would have to be pi? And then this is half of pi, so that's why this is pi over 2. Okay. So these are my degrees and my radians. Now let's talk about the coordinates. Here, your coordinate, can you think of what that coordinate is? Thank you. What is a coordinate here? What is a coordinate here? And the coordinate here. There we go. Okay, I want you guys to think of the x value as your cosine and the y value as your sine. So what this means, at 90 degrees, sine of 90 degrees is 1. Cosine at 90 degrees is what? 0. You need to think as the x value as being cosine and think of the y value as being sine. So guys, at 180 degrees, what is sine of 180 degrees? 0. And what is cosine at 180 degrees? -1. Now, question. Let me draw a triangle so you guys can see how this goes. Remember last lesson when I drew a triangle? Here's your angle theta. This is the y, this is the x, and this is your radius. So that means sine is always y over the radius, opposite over the hypotenuse. Sine is always y over the radius. Cosine is always x over the radius. Tangent is always y over x. Tangent of theta is always y over x. So guys, if I continue with this definition of tangent, what is tangent of 90? Y is 1. Your x is 0. So what is it? Undefined. It does not exist. So tangent does not exist at 90 degrees. Let's see what tangent of 180 is. Here, this is your y value and your x value. Yes, so it'll be y over x, which is 0 over -1, which is 0. Okay. All right. I'm going to pause here. I want you guys to give me, let's say I give you an angle. Let's say I give you the angle 765 degrees. Can you guys give me a coterminal angle? Give me a coterminal angle between 0 and 360. Give me a coterminal angle between 0 and 360. Okay, perfect. Somebody said, well, Luke said 45 degrees. So 765 degrees ends right here, and so does 45 degrees. Okay, I'm telling you that the coterminal angle is 45 degrees. How did he come up with that answer? Exactly. What he did was, let's say that this is 45 degrees right here. This is a 45-degree angle right here. How we got to 765 is we just added 360, and then we added 360 again to get 765. To go backwards, he did 765 minus 360 degrees, got something, and then subtracted 360 again and got 45 degrees. Is that what you did, Luke? What did you do?
765 divided by 360 times 2.
Okay, you can do that too. All right, so I'm going to have you guys figure out what is the coterminal angle of, on this little chart here. On this chart, I'm going to give you 900 degrees. I want to know what the coterminal angle is. Negative 255 degrees and 31 pi over 6. I want to know what the coterminal angles are. Okay, so to find the coterminal angle of 900, you subtract 360 and you get 540. You're going to subtract 360 again and you get 180 degrees. So we get 180 degrees. Now, if I draw you a picture, 180 degrees is right here. That is not in this quadrant or this quadrant. So I'm going to leave that blank. It's not in a quadrant. It's on the x-axis. Okay? So the point right here, we just did this. That is at negative 1, 0. So your sine of theta is 0. Cosine is negative 1. Tangent is 0. Cosecant, it did not exist. This was negative 1, and cotangent also did not exist. Okay? Now, for negative 255, what did you guys do? Yep, you should have added 360. And you'll get, what'd y'all get? Yes, if you add 360, 360 minus 255. This is what you get, 105 degrees. Which coordinate is that in? I'm sorry, which quadrant is that in? Yes, that's in the second quadrant. I know because it's between 90 and 180. So it's in the second quadrant. In the second quadrant, let me draw you a picture of a triangle in the second quadrant. This is y, this is negative x, because you went left, and this is your radius. Is sine going to be positive or negative? Y'all are starting to forget again. What do you associate the y with? So this sine, you associate sine with y. This y that I just drew is positive. That means sine is positive. However, this x is negative because we went to the left on the x-axis, right? So that means your cosine is negative because you have a negative x. So this means that your sine is positive, your cosine is negative. That means tangent is going to be negative. Your cosecant will still be positive. This will be negative. That will be negative. The reason why, sine of theta in the second quadrant, any angle in the second quadrant, the sine will be y over the radius. That's positive. That means cosecant is r over y. That's still positive. Your cosecant, however, is negative x over the radius. That's negative. That means secant will also be negative because that's r over negative x. That's negative. tangent of theta is y over a negative x, that's negative. And that means cotangent will be negative. Okay, finally, we have one that is not in degrees. We know it's not in degrees because it doesn't have a degree symbol right there. So if you do not have a degree symbol, that means this is in radians. So guys, since this is in radians, you guys should be subtracting 2 pi. So we had 31 pi over 6. You need to deduct a whole circle. Just like in the previous one, we deducted a whole circle by subtracting 360. We're going to deduct the whole circle. So we're going to subtract 2 pi. Whenever you're subtracting fractions, make sure your denominators are the same. So this is actually 31 pi divided by 6 minus 12 pi over 6. What's 31 minus 12? Okay, I'm going to deduct pi again. So I'm not going to do 2 pi over, just 2 pi. I'll do 12 pi over 6 again, because that's the same thing as 2 pi. So this becomes what? 7 pi over 6? Let's try to deduct it again. If I try to deduct it again, won't I get a negative? We don't want negative pi, so I'm going to stop right here. This is my coterminal angle. So my coterminal angle is 7 pi over 6. Just as a hint, guys, this is in the third quadrant. So now you can just draw your little triangle. This is what a triangle looks like in the third quadrant. You went down for y and down for x, or left for x. So what is sine? Is it sine y? Yeah. That's negative. So sine is negative, cosine is negative, tangent is positive. So that's your table. In geometry, you covered special right triangles. If you have a 45-degree angle, that means the sides of your triangle, well, this is a 90-degree angle right here, which means this is also 45 degrees. That means this side has to match this side. So the ratio of the sides for a 45, 45, 90-degree triangle is 1, 1, and square root of 2. This is the ratio of the sides. Okay, so let's apply what we learned in geometry to precalculus. So in my unit circle, we know this is 90 degrees. Right here, half of 90 is 45 degrees. And I know based off of the geometry ratio, a 45-degree angle has a side of 1, a side of 1, and this is square root of 2. Okay, so those are the sides of the triangle when I have a 45, 45, 90 triangle. Okay, now let's figure out the coordinate right here of this point. When I say coordinate, I know this point right here is 1, 0. I know this point on the top of the unit circle is 0, 1. We're going to figure out what this coordinate is at 45 degrees. The way we do that is SOHCAHTOA. Okay, so remember, sine of 45 degrees is the opposite over hypotenuse. Well, the opposite is always the y value, which is 1, and the hypotenuse is square root of 2. Now, we never keep a square root in the denominator. So that means it's square root of 2 over 2. That is the coordinate of the y value, square root of 2 over 2. Cosine is going to be the exact same thing. Cosine of 45 degrees is the adjacent side over the hypotenuse side. So we get the exact same thing, square root of 2 over 2. That is the coordinate for a 45-degree angle. Now, we can find this angle, and this angle. The coordinates will be very similar. There will all be some type of version of square root of 2 over 2 and square root of 2 over 2. What should this one be different? How should we make this one a little bit different? Yes, the x needs to be negative for this one. What about down here? What will this one be? They will both be negative because cosine is negative in the third quadrant and sine is negative in the third quadrant. Right here is also square root of 2 over square root of 2. This coordinate right here. However, the y value will be negative because this is the fourth quadrant. Okay, so if we're looking at a unit circle today, we learned that this coordinate is 0, 1. This coordinate is 1, 0. This coordinate is negative 1, 0. Down here is 0, negative 1. And now we learned at the 45-degree angles, it's square root of 2 over 2, square root of 2 over 2. That's what it is all the way around. Those are my coordinates. So guys, go ahead and fill that into your unit circle. Also on your unit circle, and this one's negative for y. Also, guys, I want you to put the degree. We know that this is 45 degrees. This is 90 degrees. This is 135 degrees. And this is 180 degrees. This is 270 degrees. This is 360 degrees. Okay. Guys, what's 180 plus 45? So this is 225 degrees. Okay, now we have the coordinates, we have the degrees. The last thing I need is my radians, okay? This is 2 pi. Actually, let me back up a little bit. You guys know that pi is right here. Correct? That's pi. This is pi. I'm going to break up the top section in 4 sections. Look what I'm going to do. This is half. This is a quarter. These are quarters. So this first quarter, that's 1 out of 4 pieces of pi. Because this is pi. I just got 1/4 of it. From here to here, all of this, that is half of pi. From here all the way over, this is 3 pi out of 4 pieces. And then, of course, this is 4 out of 4 pieces of pi, and the 4's cancel. That's why I'm left with pi. So that's how you come up with the radians. Let me show you another one. Right here, that's 5 out of the 4 pieces of pi. Down here, this is 6 out of the 4 pieces of pi. What can this simplify to, though? 3/2. There we go. 6 over 4 can be written as 3/2. Okay? This is 7 pi over 4. And then, of course, this is 8 pi over 4, but that simplifies to 2 pi. Okay. Also, guys, what's 270 plus 45? So we can get this coordinate, or this degree. 315 degrees. So guys, we have the degrees, we have the radians, we have the coordinate for each one. In our next lesson, we are going to figure out these coordinates, radians, and degrees. In blue, we're going to do this part tomorrow in our next lesson. Yes, you guys are trying to recreate this. So make your own little circle. You guys know these. These are easy. I want you guys to also add what we just learned. The 45-degree increments. We split 360 into 45-degree increments. So give me the degrees, radians, and coordinates of each of those locations around the unit circle. A good place to start, you know that this is pi. And it's broken into 1, 2, 3, 4 sections, 5, 6, 7, 8. Then your coordinates. Okay, just a quick comment, guys. You do not have to memorize this entire thing. The only thing that's important is just probably memorizing the first quadrant, because if you can memorize the first quadrant, these are just the same. You just got to flip signs and stuff. Just change signs. You don't have to memorize every single little thing. If you can memorize this and you understand how to find your different radians, you'll be fine. Okay? You don't have to try to memorize everything. Just be able to create it if you wanted to. You understand how it's formulated.